So when we talk about transactions, there's an important concept, and that is ACID. It's an acronym that stands for stuff that we'll talk about in just a second. ACID stands for atomicity, consistency, independence, or isolation, depending on who you talk to. It's one of those acronyms where, independence and isolation, they're referring to the same idea. And then durability. Atomicity refers to the idea that a transaction needs to be all or nothing. And I'll see if I can get this video to work. 'Cause I want it all or nothing at all. There we go. All right, it worked. The idea being either the entire transaction happens or none of it does. And so we've got two examples up here on the screen. In the top example, we have success. We are deducting money from S's account, $100, and we are adding money to C's account. Transferring money from savings to checking, for example. So we're pulling $100 out of savings, adding $100 to checking. Obviously, a customer would be pretty upset if we took money from their savings account and failed to add it to their checking account, because that's money disappearing from their account. So what happens if we are partway through the transaction, we deduct $100 from their checking account or from their savings account, and then kaboom, the database crashes or goes offline and we lose connection? What happens then? Well, if we have atomicity in our transactions, what happens then is we roll back, and that's the term for it. In the top, you'll notice the term commit. Commit means we are done. The transaction has successfully completed. In the failure case, we roll back, which means we go right back to the way we were before. So in the end state, when the transaction failed, the end state is the same as the beginning state, because the transaction failed. So we want that whole entire everything to do with that transaction canceled. We can try it again later if we want to. But we cannot leave the database in a state where half of a transaction has been completed, because that's a huge problem. For the customer, for the company, for the bank, for everybody, we can't have money disappearing. So we make sure that the entire transaction is completed. Otherwise, we roll it back. It's just good practice. So consistency, that was the A, that was atomicity, which is that all or nothing idea. Consistency means that the database state must stay valid, which means at any point during the, before or after the transaction, the state of the database has to be valid. Obviously, it's okay during the middle of the transaction, because if the transaction fails, we roll it back. But if, for example, again, going back to the funds transfer, if $250 is taken from one account, $250 should be added to another account, no more, no less. Exactly the amount of money, the balance needs to change exactly according to the transfer. Another example is if a course is deleted, all enrollments in that course need to also be deleted. So anybody who's enrolled in a course that gets deleted needs to be removed from that course. We don't want to leave people enrolled in a course that doesn't exist anymore. And that's all a part of understanding how these transactions work. It's just maintaining that consistency of the database, making sure that the database is working properly. And a lot of times the consistency part of ACID is handled by the application logic. You have to, it's programmed into the application logic to understand that, hey, enrollments, people enrolled in classes, that's dependent on the classes existing. If the classes don't exist, they should not be enrolled in the classes. We need to make sure that happens. So that's kind of a part of the logical understanding of what business rules govern the use of our application. Independence or isolation refers to the idea that one transaction should not affect or be affected by other transactions in progress. So if I am a transaction that's going through, I shouldn't be affected. I shouldn't see things changing in the records that I'm working on while I'm working on them. I shouldn't run into problems that way. And that refers to performance issues potentially. It refers to the consistency of the data that I'm working with. I need to make sure that everything that I'm working on stays. I should feel special. I should feel like I'm the only one operating on these tables at this time. And that's just how we maintain. It's part of maintaining consistency, but it's one of the rules here in terms of the ACID. And finally, and this one is extremely important, durability. Once a change has been committed, once we're done completing a transaction, it's there, it's in the database, and no matter what happens, the results of that should survive. Now, within limits, if there's a nuclear apocalypse, we might accept that some data may be lost, and that's okay. But if the database system crashes, if the power goes out, if the internet connection goes out, as soon as that data is committed, as soon as the database is saying, hey, this has been committed, I have successfully completed this transaction, then the database is responsible for making sure that that is there always, no matter what happens. And the way that that works is typically through logs. In addition to the primary record of what's happened in the actual database itself, there are extra metadata about transactions that can be used as a backup. They can be used to recreate transactions if the system crashes or the power goes out immediately after a transaction is committed. Now, if we're still in the process of completing a transaction, then the task, we're not expected to maintain durability. We can roll back the transactions that were in progress. But if the transaction has been completed, if we've gotten that commit confirmation from the database, then that should be there no matter what. And that's the ACID rules. Atomicity, consistency, isolation or independence, and durability.